Alright, people. So, okay, we are trying to recap vernier calipers, and we'll also look at screw gauge. After that, we'll look at the differentiation today. Alright, guys. So, these are few important topics which we have to really spend time understanding them. And although we have the recordings, but I think we need to actually um, definitely practice and have a personal discussion, live discussion. In case you have any doubts and all, we have to go through them, right? Okay. Oh, all right. So people, yeah, thank you for the compliments, and keep interacting, because interaction is what we need in such um, like, we are not online class, we don't have one-to-one classes, right? But still we can we still need that interaction. It will be good. So yeah, do speak up, and those who are not, feel free to actually speak up your doubts or anything that you have. That's how you will learn, guys. All right. Okay, so let us look at the recap of what we have been doing so far. Firstly, we looked at the vernier calipers. I had explained how we actually take the measurements from the vernier calipers, right? Basically, you see, we have a main scale and the vernier scale, and we can keep the object in between the two jaws here. So how do I take the readings? I have a main scale. I get the main scale reading. How do I get the main scale reading? This is how I get, right? I've shown you. Just the reading before the zero of the vernier is called your MSR, or your main scale reading. MSR stands for main scale reading. And then we need to get the vernier scale reading. So that reading which is exactly matching with the main scale is going to be your vernier scale reading, correct? So once we get these two, we are going to get the measurement with the following relation, right? So MSR plus VSR into LC. I've already explained that relation, correct? Where is that? Measurement is taken as MSR plus VSR into LC. Okay. Yeah, here. Right? Measurement is MSR plus VSR into LC. What is LC? LC is going to be one main scale division minus one vernier scale division, right? So in this case, usually you will have that on the instrument, but even if it is not given, you can calculate it by this relation, MSD minus VSD. So let's quickly look at an example problem which we haven't been able to do in the last class, guys. All right. And today I'm going to also answer that question which I gave you before we parted in the previous class, right? I had asked you why exactly only one vernier scale coincides with the main scale. If anybody has an answer to that, definitely raise your hand. We can discuss. And I would like to hear if anybody has an answer to that. If anybody has thought about it, right? I had asked a question like why exactly only one vernier scale division matches with the main scale. All right, guys. So think about it. If you haven't, if you have already, then you can speak to me. Let us look at this question here. That is saying a vernier calipers where 10 divisions in vernier scale matches with 9 divisions in main scale, and main scale has 10 divisions in 1 centimeter. So this is a particular option which you are looking at. Just look at this option and tell me whether it is the correct instrument to measure or not. Alright. So forget this option, forget the C, forget the D for now, because it's talking about the screw gauge which we haven't discussed still. Let's talk about only the first one. A student measured the length of the rod, wrote it as 3.50 centimeters. Which instrument did he use to measure it? Okay, guys. So 3.50 centimeters. Now, can you tell me what is the least count of this instrument? Looking from here, from the resolution, can somebody tell me what is the least count of that instrument? Right. So if you think you know the least count, then you can just put it up in the chat. Okay. So it seems some of the students are new here. I think Arjun, Ravina, Dharan, right? I think these are the new students here. I remember seeing all others: Karti, Danya, Vasantraj, Shivani, Hashi and Bharat. I think even Ravina Devi has attended the previous class. Alright, so only Arjun and Dharan are new. Is that so? Am I right? So you can you have a feature called raise your hand. So in case you want to speak anything or ask me any doubts, you can raise your hands. Right? Your chat won't give me any notification. All right. So let us look at the question here. What is the least count of this instrument? All right. Okay, guys. So I'll explain to you what exactly is the least count. Firstly, I had told you previously that a scale has got a least count of zero point 0.1 centimeters, right? Because you can measure 1 mm with a scale. So that's the least measurement that you can take with a scale. So if you had to write a measurement taken by a scale, and if it is 3.5, you would write it as 3.5, because you cannot measure anything here. You don't know if it is 0, 1, 2, 3, etc. You don't know anything, so you can't put any number here, right? You can't say it is 0, 0, 0, 0, 0, right? Because this alters the precision of the measurement, guys. By just adding 0, although the numerical value is not changing, but you see 3.5 is different from 3.50 is different from 3.5000. Okay, why it is different? Because this is telling us that you used a much greater resolution instrument to measure, and it is telling us precisely that there is no digit here other than 0, no digit here other than 0, no digit here other than 0, right? Whereas this, it is not telling what you can have here, because your instrument cannot measure these things. If you use a scale, your scale can tell you if it is 3.5 or 3.6, but it can't tell you if it is 3.54 or 3.55, right? Therefore they are black, they are just blank. But if you put 000, that means definitely there is not going to be any other thing other than 0. That means your instrument is capable of measuring these things. That's the underlying that's something which you have to infer from this notation of 0, adding a 0 to this. So that means basically you are able to measure up till this. So your least count won't just be zero point 0.1 centimeters, but instead it will be 0.01 centimeters, guys. Is that alright? Alright, guys? Yeah, so any doubts you have now, just raise your hands. When I have concluded based on this, the least count of the instrument has to be 0.01 centimeters. Okay, you have any doubts? Raise your hands now. Alright, so let me assume that things are okay. Now, you see, guys, if I use a Vernier calipers where 10 divisions in Vernier scale matches with 9 divisions in main scale, and the main scale has 10 divisions in 1 centimeters, with this, do I have a least count of 0.01 centimeters or not? That is the question. If that is so, then definitely I can use this instrument. There is no problem for me, right? So let us check that. Let us consider this Vernier calipers here. So it is said that it has got 10 divisions in Vernier scale, matches with 9 divisions in main scale, which means basically 9 MSD is going to be equal to 10 VSD, correct? So as I know, least count is nothing but MSD minus VSD, correct? That is the formula that we already looked at, MSD minus VSD. And he has already given that main scale has 10 divisions in 1 centimeters, right? So how much is 1 MSD? 1 MSD is already given as, he has 10 divisions in 1 centimeter. So 1 division, that is what is 1 main scale division, right? 1 MSD means 1 main scale division. So the main scale division 1 MSD will be equal to 1 by 10 centimeters. Alright, guys? Because it has 10 in 1 centimeter. So 1 division will be 1 by 10. Now I need to calculate VSD, because in this relation I already have MSD. I need to find VSD. How do I get VSD? VSD is 9 by 10 MSD. Correct? So I'll use this relation here. VSD equal to 9 by 10 MSD. Correct? Now I know how much is MSD, so I substitute here to get VSD. So my VSD will be equal to 9 by 10 into 1 MSD, which is 1 by 10 centimeters. Overall, it is going to be 9 by 100 centimeters, that is 0.09 centimeters, correct? Now least count is supposed to be MSD minus VSD. So what will be my least count? MSD. which is 1 by 10 or zero point 0.1 centimeters minus VSD, which is 0.09 centimeters. And what will be my answer? Zero point 0.1 minus 0.09 is 0.01. Correct? That is my least count. And I can see that this is definitely matching with the requirement. 0.01. 0.01 both are same. Therefore, this can be used. I conclude Vernier calipers of 10 divisions in Vernier scale can be used to measure this. That's it, guys. Okay, so definitely I can use this instrument, and because it is mains exam, you don't, and this is a single answer type question, you can forget about the rest. If this is matching, you can just go with this option. That's it. But we'll also look at why not these options are correct when we discuss the screw gauge. Any doubts here, guys? Okay. All right. So there are no doubts. Let's go ahead. So let me tell you about the screw gauge. You see, guys, a screw gauge is something which is used to measure the uh, okay, think of this. You have a screw, right? You know how a screw works. You have a screw. To drill it in, you need to put a screwdriver and you rotate the screwdriver. And as you rotate the screwdriver, the screw goes inside, right? So you'll rotate it this way and the screw goes inside. That's how the screw gauge works, correct? So basically, for a certain amount of turn, it goes a certain depth inside, correct? So the principle of work, the principle for screw gauge is this, guys. For each turn, let's say the screw gauge goes for some depth, okay, that means if I turn for one complete rotation, let's say the screw gauge goes by 1 centimeters inside, all right, that 1 centimeter, or let's say it is only 1 millimeter, so I take a screwdriver and then I rotate it by one complete rotation. As I move it by one complete rotation, let's say it goes inside by 1 millimeter, I call that 1 millimeter as pitch. Alright, guys, pitch is nothing but for one turn how much depth does the screwdriver go. That's my pitch. And once I define the pitch, what I do is the rotation, I'm going to divide it into 100 divisions. Okay. And now I'll say if for one rotation the depth is 1 millimeter, which I know, I assume that if I rotate by only one division, the depth is going to be 1 by 100. Clear? That's how I'm going to measure 1 by 100th of a movement here. How? I'm assuming since one rotation equals to one pitch, which is 1 mm, if I rotate by 1 by 100th of a rotation, that means you divide this particular rotation into small parts. That entire circumference you divide it into 100 parts, and say you only moved by first one part, then basically technically your pitch should also be, because you made 1 by 100th of a rotation, your your depth should be moved only by 1 by 100th of the pitch, correct? So that's how I'm going to measure 0.01 mm. Alright, guys, so this is the basic principle of Vernier of the screw gauge. But let us look at the let us look at a small video. I'm going to show a small video for you to understand clearly how we measure with a screw gauge. Then we are going to look at the examples of a screw gauge, and after doing that, we'll move to differentiation. So this is video that explains nicely about how we measure with a screw gauge. as you can see here. So this particular thing is a screw, and you can see the threads, and these threads are actually very uniform. So one rotation will actually move by, let's say, 1 mm. Half rotation will move by only half mm, like that. These are very uniformly threaded, they're not haphazardly threaded. So you'll keep the object to measure here in between these. So in the normal position, what happens is this rod is here, and this thing is movable. Okay, this is fixed here and this is movable. Alright guys, so what happens is, if you, okay, I'm just going to tell you how exactly we're taking. You see, this. If I have if I have an object here, then this particular length will be the measurement of the object here. Okay, guys, this is the measurement M. This will be M. So in the rest position, how will this look? This jaw will exactly match, or it will it will come till here, right? This jaw will come here, and this particular screw, if this is moving this side, then obviously this will also move this side, and it will exactly come till 0, showing that the length will be 0. But if, as you are actually trying to keep an object and measure it, you'll have to rotate this and go back. As you are rotating, this screw is going to pull back. Okay, so for one rotation, the screw is going to pull by a certain amount. Alright guys, based on that, we are able to measure how much it has pulled back, and that is going to be indicated on the scale here, how much you have pulled back, and that will be your reading. Let us see this particular thing in action. So S1 is fixed here, S2 is moving here. This is the object where you'll keep, and that will exactly match with this. With this handle you are rotating, right? You see this, as you are rotating the handle, it moved back. So does this screw, so does this S2 move back. See, you see this, as you're rotating, this is coming closer, this is also going closer. Now whatever is this, that is what is the measurement here. Alright guys. Whatever is the thing that you see, the dimension of the object you are going to measure here, this is the dimension of the object. Alright, this particular thing is the dimension of the object. That dimension of the object will be this reading here. Okay, D. Both will be same. Diameter of the object will be this, as you can see from here. And from here you are going to get the circular reading. So it is not just the main scale reading that you will get, but you will also get the circular scale reading. How much of the rotation you have completed, whether you have done one complete rotation, whether half rotation, etc. And accordingly you can get the dimension of this correctly. Okay guys, that's how the principle of screw gauge is there. Okay. Alright, I think that's for this video. But I'm going to also give you another video that's going to tell us about the zero errors, which are also something which we need to understand, because the rest of the thing is very simple except the zero error part. So that has a very nice video. I'll put you the link of that video. Alright guys, I'll put you that link of the video. I'll find it and I'll put it to you later on. Okay, so after we know this is how we are going to measure with a screw gauge. Basically, I need to know the pitch and I need to know how much rotations I have done. in order to know what will be my measurement. So my measurement therefore will be equal to the main scale reading. Previously we have seen, right? Main scale reading plus main scale reading is the reading here plus the least count of this screw gauge multiplied by the circular scale reading. Circular scale reading is this reading here. As you are rotating, this will point out to you how much rotation you have done. Whether you have done 68, 68 indicates 68% of the total rotation, like that. If you had 100 divisions, and accordingly. So least count is nothing but pitch divided by. So what is the least count in the case of the screw gauge? How do we calculate that? Usually screw gauge pitch is given on its instrument. Pitch is nothing but for one complete rotation, how much the depth has been moved, right? How much the jaw has moved for one rotation. Let's say if that is 1 mm, then my pitch of the screw gauge is 1 mm. Now if the circular scale has got 50 divisions or 100 divisions, whatever it may be, my least count will be nothing but that pitch divided by the number of divisions. Correct, guys? So if I'm calling the pitch as h, then h divided by the total number of divisions n is going to give me the least count of my screw gauge. So let's say the least count of the screw gauge is 0.01 mm. My measurement will be nothing but the main scale reading plus this particular least count, which is 0.01 multiplied by the circular scale reading. Okay, guys. So let's say the circular scale reading here is 68. Then 68 has to be multiplied by the least count, which is 0.01 mm or 0.001 centimeter. So I'll multiply with this plus my main scale is reading 5.2. I'll add both. So I'll get the value as 5.268. That will be the diameter of this. Alright, guys. So the key is finding the least count. Least count is going to be 1 by 100 of the mm. Why? Because I've got 100 divisions here for 1 mm. Okay, guys, so since you will be having the recordings, you can view this for greater depth, and I'm going to skip the calculation part for the screw gauge because I am sure you'll be able to understand this. Except we'll be doing the zero error part that we'll discuss after you watch the video. Alright, guys. So let us proceed next to the differentiation part. Okay. Okay, guys, so let us look at the mathematical tools required clearly. So I'm sure trigonometry part you can understand once you go through the videos, so therefore I'm going to skip that. But I'm going to tell one word about trigonometry. Basically this is designed so that um, we can easily get the relation between the sides, provided you know the angles of a triangle, or vice versa, like that, right? So we are defining the ratios because for a triangle, if you fix the angle between the two edges, and if you know the angle here for a right angle triangle especially, then basically your length of and if you know one of the three sides, you just know one side, that's sufficient for you to actually freeze the other two sides. Okay, how? Because think of this like this. Suppose you have one ray here. This is just a ray. Ray is just extending infinitely, correct? Ray is extending infinitely. Now you have another ray that's also extending infinitely. Now think this can rotate anywhere. But say you have actually fixed a particular angle, say 60 degrees, and you have fixed it. Now you know that this is a right angle triangle, so definitely at some point the third side should be at 90 degrees to the base. Alright, so it should be something like this, 90 here, or it should be at some other point here, etc., etc., different points. But let's say you have fixed the length of this. That means let's say you have fixed it as some units, 5 units, let's say. Okay, then what will happen is immediately from that point you will put a perpendicular, and as you put a perpendicular, the other side will also get fixed, right? So this is fixed, provided you fix only one thing, right? So that is the reason for that is because it's a right angle triangle. So the moment you fix this angle, obviously the other two angles will also get fixed, and the moment you fix a side, the other two sides will also get fixed. Alright, guys, that's unique about a right angle triangle. So what's my advantage? Alright, this relation is fine. What's my advantage by having such a thing? What I do is, think of this. Suppose I have the same angle 60 degrees and it's a right angle triangle, and let's say I have only one unit here. Corresponding to one unit, I define my sides, this side and this side. Okay, let's say this side is x and this side is y, corresponding to one unit. Now think of this, guys. If I have corresponding for the same angle 60, if I have for 5 units, how much will be this side and how much will be this side, the hypotenuse? It's very evident, right? These two triangles will be similar triangles because all the three angles are same between this triangle and this triangle, right? Because see, guys, I have not changed the angles. I've only changed the length. Instead of going till 5 units, I've only freezed at 1 unit here. So you see, obviously this triangle and the bigger triangle will be similar. Therefore, if this is 1, then this will be x and this is y. Then obviously when it is 5 here, this length will be 5x and this total length will be 5y. Okay, guys. So that is the unique thing. If I measure x, if I measure y, obviously I can also measure for any triangle. If the angle is same 60 degrees, I can measure these two things also. Alright, guys, that is basic advantage of measuring for a unit triangle, right? So naturally it is of interest to me to measure this x and y, correct? Therefore, as simple as that, I am calling this x as a particular thing. I'm calling this y as a particular thing. What am I exactly calling y as? I'm calling x as tan 60. Okay, the tan ratio, because it is opposite by adjacent, that is tan 60. I'm calling it like that. Similarly, I'm calling y as, actually it is going to be 1 by cos 60, which is nothing but secant 60. Okay, I'm calling y as secant 60. Why 60? Why am I keeping 60? Because obviously you see, if I change the angle, these ratios will change, right? So therefore the variable that I'm defining has to be in relation with the angle. Therefore I'm adding that angle also in the variable tan 60, like that. Does this make sense, guys? That's how I'm defining the ratios. After I define the ratios, the rest of the things you can follow quite easily. Surprisingly, the class is so silent, guys. Any doubts or anything? What's happening? Any doubts? Are you going good? No response. Okay. Alright. Shiva Sailanathan. Okay, can you raise your hand, Shiva Sailanathan? Oh, I'm sorry. Okay. I had my earphones. Were you able to hear me up till now?
Ah, yes, sir.
So is
Yeah,
everything clear?
yes, sir. Everything is okay, sir.
Okay,
No
sorry. I
doubts
had the
till now.
earphones on, so I couldn't actually listen to many of the hand raises.
Sir, your voice is breaking.
Okay, is
Your
it
voice is
clear?
breaking, sir.
Or is it breaking?